Our Data Communication Project, Group 13. Introduction. Based on the scenario that been given, we need to figure out how the flow of data from home network to UTEM facilities. On the scenario, a UTEM lecturer is trying to access the ULAN system located in the UTEM network facilities. The lecturer is using his modem to connect to the public network before able to connect to the UTEM facilities. From the UTEM network, the data then was forwarded to IT center where the ULAN system server is located. For this project, we use packet tracer to create simulation for the network. All the IP address is manually assigned and calculated. On the home network, we use class C network, and for the UTEM server, we use class A network. Our network space. So, this is our private network, and this is our UTEM server. OSI layer model. Layer 7 to 4. Layer 7, application, graphical user interface, primary user interface with communication system. Layer 6, presentation, supports the functionality of the appliance layer by providing services like formatting and translating. Layer 5, session, maintains the transmission path by synchronizing packets and controlling access to the medium by the application layer. Layer 4, transport, ensures the standard of transmission and determines the simplest route of transmission of knowledge using the network layer below. Layer 3 to 1. Layer 3, network, finds a route for transmission of data and establishes and maintains the connection between two connected nodes. Layer 2, data link, creates, transmit, and receive packets, controls the physical layer. Layer 1, physical, translates data into transmission bits and transforms the obtained bits into functional data for the above layers. OSI layer model based on our project. As the top layer of the OSI model, application layer is the layer that computer can be interacted directly with from UTEM IT Center. The lecturer can access the ULAN page by typing http://ulearn.utem.edu.my using browsers such as Google Chrome and Mozilla Firefox. For the browser is called application layer. Then it will reach at the next layer, which is presentation layer. It will translate between application and network format and transform data into the format so that the ULAN system server will understand. Other function of this layer includes data encryption and data compression to make sure that the data is secure. After that, the data will reach the session layer, which is controls the connections between lecturers, computers, and ULAN system server is establishing, managing, and terminating session. Whenever lecturers visit ULAN website, the lecturer's computer is creating session with the web server. The session layer is commonly implemented explicitly. Next, the data will be reached at the transport layer. In this layer, the data will be coordinated to the data transfer process, which is how much data will be sent, at what rate, by what behavior, and so on. Two important protocols for these layers are the TCP and UDP. Next, at network layer, the raw data now will be encapsulated into packets data between networks. The sender and receivers IP address is being put in the header network layer. IP address of UTM server, which is logical address, and source IP address is added as destination. Then, the data will be reached at data link layer. At data link layer, the data will be framed. The sender MAC address and receiver MAC address will be added to the header. The data encoded will convert into bits and will move to physical layer. For the last, the data will be reached at physical layer. At this layer, the data which is in form of bits will be transferred to networking media through fiber optic, cable, wireless to reach the destination. Lecturer connects the PC with modem and it will transmit one individual bits from one node to another node. Subnetting calculation. Here is our subnetting calculation. Based on the scenario, we choose class A and class C as the IP address for the home network and UTM server. We calculate the IP address manually to assign on the all device on both networks. Subnetting table. Here is our subnetting table. TCP/IP setting manual. For all the devices including server, all the IPv4 address are manually assigned based on the addressing table. Here is our IPv4 configuration on server. To make sure the home network and UTM server communicate to each other, we need to some configuration on R1. Some of the configuration that we configure are NAT, access list, RIP, and DHCP. First, we using NAT protocol. The purpose we use NAT, which is Network Address Translation, is to enable private IP networks that use unregistered IP address to connect to the internet. NAT implement at broader net devices such as router, so it connecting two networks together easily, and translate the private addresses in the internal network into legal address before packets are forwarded to another network. Basically, based on our diagram in packet tracer, for example, we configure NAT in router to act as an agent between the internet or public network and a local or private network, which means that only a single unique IP address is required to represent an entire of computers to anything that outside of their network. So, on this router, we assign dynamic NAT. This is because single private IP address is mapped with single public IP address. A private IP address is translated to a public IP address. Here is output when show protocol. We use NAT process on R1 to convert from the private address to public address. It is important aspect for firewall security to user. Using ACL protocol, access control list is the concept of rules that usually filter the traffic network. So we configure standard ACL in router 1. It contains a list of conditions that packets and help to determine when to allow or deny network traffic. We use ACL to provide a security to users' network. Without ACL, it can allow to enter or exit and will make it more vulnerable to unwanted and lead to dangerous trafficking. Here is output when show protocol. Using RIP protocol. RIP, Routing Internet Protocol, is a well-known as routing information protocol. Is used by routers to exchange routing information on a network, so it is used to determine the most efficient way to route data on a network and prevent from routing loops. On the R1, we use RIPv2 because RIPv2 is considered to be a classless routing protocol, meaning it will include subnet information when it sends routing updates. In this, also allows this contiguous network to be supported. Here is output when show protocol. Using DHCP protocol. DHCP, Dynamic Host Configuration Protocol, is protocol for automatically assign TCP IP information to client machines. For example, DHCP is one of the methods easier for administrator if wants to change the IP addresses of large number of systems. And in addition, instead of reconfigure all the systems, they just edit one DHCP command on the router 1 for the new set of IP address. Once we reboot the network, it will change to new IP address that we set before. Here is output when show protocol. Manual TCP IP versus automatic TCP IP. Here is the difference. Manual TCP IP. User need to configure manually. Possibility of entering incorrect or invalid IP address. Wrong configuration can lead to network issues. Automatic TCP IP. IP address automatically applied to client computers, user device, ensures to user always use correct configuration, updated automatically to reflect changes in network structures. Thank you.